All right, now let's take a look at our single replacement oxidation reduction reactions. So again, redox is a movement of electrons. So in our previous examples, when we were just looking at our net ionic equations, we ended up with this final equation that looked like this. We had some zinc solid and some copper 2 ions. They gave us copper solid and some zinc ions. So I had some oxidation numbers here. I had 0 for my zinc, plus 2 for my copper, 0 for this copper, and plus 2 for this zinc. Because remember, if I have an ion, okay, that oxidation number is just the ion charge. And so when I have these single replacement reactions, what drives them is this movement of electrons. And so I have an overall plus 2 charge from here and an overall plus 2 charge from there, so they do equal each other. And so here we do have a redox reaction that's our single replacement. Okay, so here is that silver nitrate and copper giving me copper 2 nitrate and silver. And so you can see we've got our oxidation numbers. And so they change. And again, the nitrate, that plus 5 and the minus 2, in 141 you'll learn how to assign oxidation numbers when something is covalently bonded. Okay. All right, and so here we have a redox reaction. If I were to write out my net ionic equation, I would get 2 silver ions plus my copper solid, giving me my copper ion plus 2 solid silvers. Now, we still have those 2's in front of the silvers because all of my charges have to equal out, okay? And so I have a single displacement reaction. This reaction is driven by the fact that copper is more active than silver. Okay, so copper is more active than silver. What that means is copper wants to be an ion more. Okay, and how do I know that copper is more active than silver? From our activity table. Okay, so here I have my activity series, and we were just looking at copper and silver. So here's copper, and here's silver. So copper is what is known as a stronger reducing agent than silver, okay? And so remember, redox, oxidation is loss, reduction is gain. So silver gained electrons. So silver was reduced. Copper is what is known as the reducing agent because it facilitated the reduction of the silver. Okay, so in this case, copper was oxidized and was the reducing agent. Silver was reduced and it was the oxidizing agent. Okay? All right. And so when we have any of these reactions, we have to look at our activity series and figure out what's more active. Now, if the more active element is already an ion, nothing will happen. Okay? So one thing to point out too is that we've got hydrogen here. Some elements are going to react with hydrogen ions to release hydrogen gas. Other elements will react with hydrogen ions or with steam to release hydrogen gas. And then some elements, these guys up here, are so strongly reducing that they'll react with water to release hydrogen gas. Okay? All right. This is just another picture of the same thing. Just another way of viewing the activity series. So in our next video, we'll do some practice.